Ah. Okay. Okay. All right. Huh. Hi guys, very good morning to all of you. Welcome to another class of geography. So I hope you people have taken the tests, right? So it is very important that you people take the tests. Don't have any excuses. Don't think I have not studied, I'll do it later, I'll do it after studying. Don't have those things. Okay. So whatever questions that I have given you today is basically from the 6th standard NCRTs. Okay, I have taken the MCQs from the end of the chapter and I have just given it there. So it is pretty very simple and straightforward. It is okay if you have not done entirely good. Don't try to gauge yourself or your performance right away. Okay. It is all about getting familiarized with the concepts, the process. Okay. So forget the end consequences, learn the process very well. Okay. So I hope everyone has taken the test seriously. I have given only MCQs, I have not given the mains question because it was the first class yesterday, I didn't do anything. So from tomorrow onwards you will get around 5 MCQs and 1 mains question. Okay. So develop that habit of answer writing. So once we start our mains questions, I will actually keep telling you how to go about your answer writing, what needs to be the actual essence or facets of answer writing, and the demand of the questions. So we'll be discussing that over a period of 1 month. So you will get used to it. Okay. So today we will not waste much time. We will start off with the classes. Okay. So today, as I told you, we will be starting off with okay. So we'll be starting off with geomorphology. Keep jotting the the literature down, jotting the points down. Okay. So basically, as I told you in the beginning yesterday, geomorphology basically is, geo means earth, morph means shapes. The study of shapes on the surface of the earth is known as geomorphology. Okay. It should be very clear. So geomorphology is the study of shapes on the surface of the earth. 1. 2. It does essentially the study on lithosphere. Okay, it does essentially the studies on lithosphere. Yeah, one more thing about the MCQs, I will tell you the answers at the end. Okay, just someone remind me so that I'll just discuss that answers. Pretty straightforward, but I'll discuss it. Okay, we'll get on to the classes first. Praveen, today's prelims questions were shuffled. All right, but it was pretty straightforward. But let's see, we'll discuss it later on. Okay, now let us go with the flow. All right. So basically, we are starting off with geomorphology, which deals essentially with lithosphere. Okay, what is happening within the lithosphere? All right. So if I say lithosphere, it is mainly land. Right. The actual definition of lithosphere you will get to know once you read the interior of the earth. All right. But now lithosphere, according to you, is just land. Okay. So when you see land, the first thing that appears is basically what? The first thing that you see on land is rocks. Right. So if you have to go into studying of geomorphology, first you have to understand the mechanics involved in rocks. What are rocks? How is it formed? What are the different types? These are the things that you should have an idea about before you move into the advanced topics of geomorphology. Because at the end of the day, whatever land that you see is nothing but assemblage of rocks. Correct? So this assemblage of rocks is creating a shape. So that shape is what is given different names. For example, it may be mountains, it may be plateaus, it may be plains, whatever the name may be, it is nothing but collection or assemblage of rocks. So rocks form the basic unit in geomorphology. Okay. So this basic unit you should have much clarity over. Okay. So the first topic that we'll be dealing is rocks. All right. So before we start dealing with rocks as such, all right, it is necessary that you need to have some idea about terminologies. Since geography is a technical subject, you should have some idea about terminologies that come across in geomorphology as a chapter. Every chapter will have its own terminologies. So the first class of every chapter I will deal with that terminology, so that once you read that chapter, you should understand what are these terminologies. Okay. So what are some terminologies? Relief, topography. Okay. Gradient. Minerals. Okay. So in this particular geomorphology, these are some terminologies that you should have some idea. Okay. So you might have heard people telling, I mean, if you have started reading geography, NCERT, you would have come across them using the term high relief feature, low relief feature. Okay, they use topography in different terms. Okay, so what does it actually mean? You should have an idea about this. Even gradient is a term that they keep using it everywhere else, right, in the book. So you should have some idea about what this means. So the first is relief. Okay, relief, if I have to define in geography, relief is a point that is taken with reference to the sea level. Okay, it is an point at a particular altitude that is taken with reference to the sea level. I'll repeat again, it is a point with respect to altitude. Okay, point with respect to altitude, okay, that is taken with reference to the sea level. There is one more term, I'm trying to recollect one more term, but anyways, yeah, I'll get it. Okay, relief is nothing but a point, yeah, altitude, okay, latitude, longitude. Okay. Fine. So relief is a point with respect to altitude that is taken in reference to the sea level. That is what is relief. For example, see, you know what is sea level? Sea level is the point up, the sea level is a point where, you know, the seas meet the land. That is known as the sea level. All right. For example, if this is a land, okay, so let us say that it is at this point, that the sea meets the land. Okay, it is at that point that the sea meets the land, then that is known as the sea level. So that becomes the point. So I can mark two things. Okay, I'll do this. Okay, I'll mark C, B and A. I have marked 3 points A, B, C. Now if I have to define relief of A, I am going to define relief of A as high relief feature. I am going to define relief of B as intermediate relief feature. Okay, I am going to define C as low relief feature. Okay, so I hope you are understanding this. Whatever point I am taking with respect to altitude, okay, from the sea level. So if I go altitude, you know what is altitude? Altitude is vertically upwards. Have this in your mind, don't get confused. Whenever I use the term altitude, okay, altitude means vertically upwards, elevation. Mountains are high altitude features. Okay, so altitude means elevation, that means vertically upwards. Latitude, okay, latitude means, if in geography if I use the term latitude, it means horizontal. If I say latitudinal distribution, okay, this latitudinal distribution means horizontal distribution. Okay, we'll come back to this, but just know what is altitude and what is latitude. Whenever I use the word latitude, it means horizontal distribution. That is, if I say, let us say, if this is North America, okay, if this is North America, if I say the latitudinal distribution of North America, how are the latitudes distributed? It is parallel. Okay, this is how the latitudes are distributed, correct? So if I say latitudinal distribution of vegetation in North America, okay, if I say latitudinal distribution of vegetation in North America, I go like this, I go horizontal, getting it? Alright, now there is a mountain here, there is one mountain here, the name of the mountain is known as Rockies. Okay, the name of the mountain is known as Rockies. Now, if I say altitudinal distribution of vegetation in Rockies, if I say altitudinal distribution of vegetation in Rockies, if this is the Rockies, altitudinal wise is like this, vertically upwards. Altitude is nothing but elevation. Okay, so we start, spatial distribution is done vertically upwards. Whenever spatial distribution is analyzed vertically upwards, it is altitudinal distribution. Whenever it is done horizontal, okay, whenever it is done horizontal, for example, see, I analyze this area, I am going to this area, I am going to this area. So I am analyzing it horizontally, that is latitudinal distribution. The next is I analyze this layer, then I analyze another layer, then I analyze another layer, then I analyze another layer, that is altitudinal distribution. Okay, have this in your mind because it keeps coming up and I will keep using it. So you should not get confused then. Alright. So fine. So I'll clear the doubts once I'm done with the topic, otherwise it kind of breaks the flow. Now see, so when I say a relief feature can be three types, okay, high relief, low relief or intermediate relief. So usually the mountains are known as high relief features, the plateaus are known as intermediate relief features, and the plains are known as low relief features. How am I deciding it? The altitude is the reference. So since if this is the reference of sea level, since C is very very close to sea level altitudinal wise, it is low relief. B is very very, to an extent further, but not very high, hence it is intermediate. The next is A is very far from the sea level altitudinal wise, hence it is high relief feature. Okay, so this is where they keep using relief feature. Alright, so that is about it. The next comes topography. Okay, the next is topography. Topography, if I have to define, topography is the surface configuration of the land. Okay, the surface configuration of the land is known as topography. Okay, I'll repeat again, the surface configuration of the land is known as topography. For example, all right, so all these are 1, 2 and 3. These 3 are surfaces. Okay, all this 3 are surfaces. Now, if I Abhishek, longitude I'll tell later on. Okay, don't worry about it. What was I telling? All right, see, topography. Topography means surface configuration of the land. Okay, surface configuration of the land can be of 3 types. Okay, how is the profile of the land when I travel over the land for certain periods of time decides what type of topography a region is. Okay, what is the profile of the land when I travel over it over a period of time, okay, decides what topography a particular region has. Getting it? Now look at this, I am traveling from here to here, I am just traveling over a straight line. In reality, no land will have this type of surface configuration, that is, it will not be perfect flat. However, for academic purposes, if the surface configuration is like this, that is, it is flat, alright, it is known as flat or featureless topography. Okay, it is known as flat or featureless topography. Okay, now coming to this, look at the profile. The profile is highly irregular, the profile is very very dissected. Okay, the profile is very very dissected. All right, so such type of topography where it is highly dissected, very irregular, rough, these are known as rugged or dissected topography. rugged or dissected topography. Okay, all right. Now, there is some regularity in this. It is not rough. Okay, there are crests over a particular distance and then trough over a particular distance. There is smooth movement. However, though it is not completely flat, it is regular crests and troughs. Okay, the profile has regular, smooth crests and troughs. Wherever the surface profile has regular, smooth crests and troughs, such profiles are known as undulating topography. Such profiles are known as undulating topography. Okay, so you got to know the three types of surface profiles. The surface configuration of the land. One, if there is regular smooth crests and troughs, it is known as undulating topography. If it is highly irregular, very dissected, it is known as dissected or rugged topography. And then it's completely flat, there is no feature at all there. Okay, then it is known as the flat or featureless topography. Okay, so the most common type of topography that you will find is undulating topography. Okay, undulating topography, see, whatever year, this point, this was mountains, this was plateaus, this is plains. Plains are nothing but more or less flat surfaces. Okay, I told you, in reality you will not find exactly flat. So plains are usually nothing but undulating topography. Okay, plains are usually nothing but undulating topography. Next, highly dissected topography. These are mainly found in plateaus. These are mainly found, I'm repeating it again, mainly found in plateaus, not only found in plateaus. Okay, some plains can also be rugged, not necessary that it has to always be undulating. Okay, but majority of the plains are undulating topography. Okay, and most of the plateaus are rugged or dissected plateaus. Okay, the reason you will understand, because the plains are formed by rivers. Okay, the plains are majorly formed by rivers. Okay, how rivers will create plains, you will learn maybe in a week or so, once you start reading about riverine landforms. Okay, now that is not necessary, but just know undulating topography is formed by plains because of the actions of rivers majorly. Rugged or dissected topography is formed over plateaus, and the reason for ruggedness, is the climate there, prevailing there. Okay, is the climate prevailing in that particular region. Okay, this example for this is Meghalaya Plateau. Okay, example for this is Meghalaya Plateau. The climate of Meghalaya is very different compared to the climate of Rajasthan or compared to the climate of Kerala, right? So the climate of Meghalaya is the reason why that rugged topography is created. How, we will see over a period of time, that is not necessary now. Okay, so this is more or less about the topography. I hope you people have understood this. Okay. How about remembering terms? First understand. Okay, see, don't jump to the second level of how to remember things. Yes, you have to memorize, that is the innate necessity of this exam, but don't put pressure in yourself that I want to memorize everything at one go. There are always levels. First understand the subject, get familiarized with the topics. Okay, then comes the memorizing part. Okay, don't worry about memorizing right now. Understand the concepts. Badland and karst topography, Subramania, I'll tell you. I'll see, they are just, see, badland is more or less like this. Okay, it is created because of actions of man. Karst topography is nothing but topography that is formed over limestone regions. You will get it when the time comes. This is just basic terminologies. Shivani, where we have flat topography, I just told you. In reality, in nature, it is not like this. There is nothing called completely flat. There is no profile at all. All right. So it is just for academic purposes that we are just telling. So in textbooks, whenever they say flat, featureless plains, it is more or less this itself. Okay, you only see how can there be completely flat. There will be some actions of wind, water to create some levels of irregularity. So in reality it is not. What is a tabletop? In which context, Rashmi? Tabletop, which context? I don't know what you're telling. Table lands are plateaus. Okay, table lands are plateaus. Undulating is nothing but smooth. What did I define? I use my own definitions. So smooth, regular, crests and troughs. Okay, these are undulating. Okay, there is regularity in it. All right. Can we take notes when you're telling? You have to take notes when you're telling, Basavaraj. Okay, you have to keep on jotting down. Initially it will be difficult, I understand, but that is how it has to be. Okay, you have to get used to, see, there is something called aptitude, ethics, integrity and aptitude. What is aptitude? Aptitude means the ability of a person to grasp things. Okay, and that is the most important facet for being a bureaucrat. So develop that habit from now itself. You have to grasp that assimilative capacity should be very high. Got it? So have that ability or develop that ability. You should learn how to grasp things very fast, because it is not that you will have a same job profile in your career the entire 25 to 30 years that you are going to serve, right? Every year it is going to change. They keep putting you in all the different things possible. Okay, and you don't have time to learn taking your own luxurious time. You have to be very, very quick in grasping things. So anyways, so that is one. You have to take notes. That is the point I'm trying to make. Keep taking notes. I told you, I am going to dictate only those parts in the geographical part which is not there in your NCERT. Okay, that I am going to do. The next is for a country like India, where we take the starting point of sea level with respect to east coast or west coast. Okay, see, sea level is an average point. They take where the land is meeting the oceans. It is not that there is one point, more or less at what altitude the sea levels are meeting, they take the average of it. So east coast, west coast, it doesn't differ like that. All right. So fine. Can runoff Kutch be an example of flat topography? Flat, see, runoff Kutch is, see, if you want the reality, runoff Kutch is like this. Okay, this is runoff Kutch. Okay, runoff Kutch is a depression like basin. That is why the rivers, that's what it goes off into. I have not taught you all those things. It is known as inland drainage. The rivers will not go into the ocean. The rivers will come and stop here only. Why? Because it is like a saucer. Okay, so that's what I told. Why are you trying to search for something that doesn't exist? Flat topographies are not there. Okay, so anyways, getting back to the basics part again. So I hope you people have got clarity on what is a relief and what is a topography. The next is gradient. Okay, so this gradient as a term is not only important for geomorphology, but it is very important for the entire subject of geography. Okay, so understand this. All right, understand this term gradient. All right, so basically gradient means, in a very layman terms. Okay, in a very layman terms, gradient means difference. Okay, gradient means difference. All right, so gradient means difference. Okay, when I say difference, the difference is if there are 2 points. Okay, if there are 2 points, okay, there is a difference between these 2 points. There is a difference between these 2 points. Then there is said to be a gradient that exists between them. I hope you are understanding that. If there are 2 points A and B, okay, and if these 2 points A and B are not at same level, whatever it may be, okay, we will get into that. But if these 2 points are not the same, for example, I am rich, someone else is poor, or I am poor, someone else is rich, there is a gradient. Okay, there is a socio-economic gradient that may exist between us. So whenever these 2 points or 2 entities are not the same, okay, whenever these 2 entities are not the same, all right, so the gradient is said to be existing. That is one. Okay, the first point. All right, the first point is whenever there is a difference, there is a gradient that comes into existence between those 2 points. Second, whenever there is a gradient, this is nature, I am talking about nature, whenever there is a gradient, nature tries to balance the gradient. Okay, whenever there is a gradient, the nature tries to eliminate or reduce the gradient so that the balance prevails among them. I hope you are understanding this. Gradient means difference, that is one. Okay, gradient means difference. Okay, so this point A is, let us say, I am surplus of something. This point A is surplus of something. This point B is deficit of something. Okay, this point deficit. Okay, suddenly I forgot the spelling of deficit. Anyways, if I am wrong, I am sorry. Anyways, see, A is surplus, B is deficit. Okay, so there is difference between them. So there is a gradient that exists, and nature always tries to reduce the gradient by bringing balance amongst the two entities. This is what you have to have in mind. Okay, so you understood what is gradient, you understood how nature reacts to a gradient. Now let us see examples. Okay, you will understand examples. All right, now the first example is, okay, air and wind. All right, what is air and what is wind? Air is nothing but a mixture of gases. Okay, air is nothing but a mixture of gases. All right, so this air that is a mixture of gases, all right, is just standing there. Then I call it air. Okay, this mixture of gases that is standing there starts moving. Okay, it starts moving from one point to another point. Then that particular mixture of gases becomes winds. Getting it? So basically, air means mixture of gases. This air is transformed into wind because of the movement. It moves, so the air becomes wind when it moves. Okay. Now the question is, why should the mixture of gases move? Why should the mixture of gases move? The mixture of gases will move, that is, wind will come into existence. Okay, wind will come into existence if there is something called pressure gradient. If there is something called pressure gradient, that is, point A is, let us say, high pressure, point B is, let us say, low pressure. Okay. Now don't get into the aspects, sir, why is this high pressure, why is this low pressure, that you learn over a period of time. Understand the basic this thing. Okay. So point A is high pressure, point B is low pressure. In that case, there is a gradient that exists. What type of gradient? Because it is pressure gradient. Okay. So what happens now? Nature, to reduce this gradient, to bring balance between the 2 points, will send something, and that thing is winds. Okay, it is winds that move from surplus to deficit, that is high pressure to low pressure, and that is known as winds. See, winds are coming into action because of a gradient that exists. Getting it? Now I'll take one more. Okay. Now the next is, one sec, sorry. This is sea level. Okay, this is sea level. This is a mountain. Okay, we will take our Ganga, the river Ganga. Now this Ganga river rises somewhere here. It moves down the mountain. Okay, it moves down the plateaus and plains and then joins the oceans. Okay. Now my question is, why should the river move only like this? Why can't the river move, come like this, go back like this? It can go wherever it wants to. Okay. Why is it that the river will always flow from point A to point B? Okay. Think about it. Why is it the action of nature trying to balance something? It is is it an action of nature trying to balance something? Yes, it is. See, the main job of the rivers is to meet the ocean. Once it meets the ocean, it will not again start moving in the ocean also. Getting it? Once it meets the ocean, it stops. So, there is some movement of water happening over the land. Why is that movement happening? Because it is trying to balance something. So, if it has to balance something, what has to be there in the first place? Gradient. Okay, gradient has to be there. Now, if you look at point A, where it is? Point A is a high relief feature. Point B is a low relief feature. Okay, point A is surplus, point B is deficit. Okay, now because there is a gradient, can I say that? Point A is high relief feature, point B is a low relief feature. So there exists a gradient. This gradient is known as slope gradient. Okay, now because slope gradient exists in nature, any type of gradient that exists in nature, the nature will always try to reduce the gradient by bringing balance between them. There is a river that flows. Okay, there is a river that flows. Okay, so river will flow up to the slope gradient that exists. Now, if once it reaches point B, the river will stop its flow because at B, the slope gradient is 0. There is no more difference. If I take B as like this, okay, and if I take, let us say this is B, this is BZ and this is BA, a point very close to B, slope gradient reduces. Finally, when the river reaches to B, slope gradient is completely 0. Getting it? So, I hope you are understanding this. The river is coming into existence because there is a slope gradient that exists. Okay, and it stops at B because slope gradient becomes 0. So, the next question that is coming is, sir, there is a gradient that is existing. Now, to reduce that gradient, rivers are flowing, but how is the river reducing the gradient? The way that river is reducing the gradient is, if I allow river to flow over this mountain for 10,000 years, for 1 million years, I will assume that this is Himalayas. If I allow Ganga to keep flowing over Himalayas for 1 million years, the Ganga, I told you, the main job of nature is to reduce this gradient. Ganga will obliterate or destroy this entire Himalayas. After 1 million years, this entire mountain will become like this. See, the slope gradient is reducing. Getting it? And what has reduced the slope gradient? It is the rivers that have reduced the slope gradient. Getting it? So, this is another example. Alright, I will take another example. Okay, we are discussing about gradient. I am talking about different types of gradient. So, if I take this as the surface of the earth, be attentive. If this is the surface of the earth, got it? And let us say this is the surface, okay, and this is the inner part of the earth, that is core. Okay, there is the mantle in between. For now it is not needed, forget that. Just take, this is the surface, we can call it crust, okay, and this is the core. Okay, there is surface and core. Now, as I start moving from the surface towards the core, if I put this point as A, if I put this point as B, okay, as I move from, this is the surface, this is the core, the innermost part, that is let us say 5000 degrees inside the earth. Okay, so will A and B experience the same type of environmental conditions? No, correct. B is not facing that much of pressure, overload pressure, whereas A, which is 5000 kilometers below the earth surface, is facing very high levels of pressure conditions. Okay, so can I say in that case between A and B there is a gradient that exists? In that case, because there is A and B are 2 points in the earth where there is a gradient that exists. So what type of gradient? From between A and B, the type of gradient that it exists is density gradient. Density gradient, that is, since as I go interior of the earth, the pressure conditions is more, the overlying load is more, the rocks are more compact, and hence they are more denser. Okay, denser. Mass by volume is density. Okay, for less volume there is more mass, that means it is high density. Okay, so at point A the rocks are very dense. Okay, at B the rocks are less dense. I hope you are understanding. So at the surface less dense rocks are there, as I move to the interiors the density is increasing. So I can say that there is a gradient that exists. That gradient is known as density gradient. Okay, now whenever nature sees gradient it tries to reduce it. Okay, that is, from surplus it has to send something to deficit in order to balance this gradient. Now here the river is going to send what we call as magma. Okay, here the river is going to send magma. The movement of magma happens like this. Now what is the constitution of magma, how exactly is it formed is not your case right now. Okay, don't try to jump there. Okay, understand the concept of gradient properly. Alright, so this is density gradient. To reduce the density gradient, what is created? Magma. Okay, so all in all, gradient is nothing but difference. Getting it? The difference that exists between 2 points. Okay, and to reduce this difference, the nature always creates a force. Okay, and that force can be in the ways of magma, it can be rivers, it can be winds. Okay, there are many more which you will learn over a course of time. Okay, so this is the, so whenever they say atmospheric gradient, okay, that is, there is some type of instability between 2 points in the atmosphere. Okay, and majorly whenever they say atmospheric gradient, it is pressure gradient. Okay, it is the pressure gradient, because atmosphere majorly is dealing with putting pressure on the land, right? So if there is gradient that exists in the atmosphere, it is with respect to how much pressure, you know, the atmosphere is putting over the land. Alright, so you can take it as atmospheric gradient is almost same as the pressure, or almost it is same as the pressure gradient. Okay, so this is about gradient. Can it be temperature gradient is correct. Okay, it can be temperature gradient. Okay, temperature and pressure are almost interrelated. That is, when I increase the, see for example, I told you A is high pressure, B is low pressure. Okay, high pressure invariably means low temperature. Okay, high pressure invariably means low temperature. Low pressure invariably means high temperature. Getting it? So I can also say there exists temperature gradient here. Okay, there is high temperature here, hence low pressure. There is high temperature here, hence there is low temperature here, hence it is high pressure. Okay, so you will learn those things in climatology very much in depth. Don't worry about it. Okay, all right. Yeah, so gravity and gradient you people are telling, good, that's fine. So this is about gradients. Okay, the next, I hope you people have understood this. Any doubts with respect to this, you people can ask me. All right. So the next is minerals. Okay, we'll do minerals with rocks itself. Okay, rocks and minerals. Karthik, don't worry about crust, high pressure and temperature. Okay, I will deal with that later. Understand the gradient part. Okay, once you read the interior of the earth, you will understand how it goes. Are profile and topography the same? See, profile can be anything, but the profile of the surface of the land is topography. Getting it? Okay. We'll move on. All right. One thing is, unnecessarily don't make things complicated. Okay, and don't put things in the chat box to make others feel insecure. Okay, just because you know some aspects of it, it is not good. Okay, what I am telling is enough for people who don't worry about these things, whether what other people know. Understand what I am trying to tell. I will take it through levels. Okay, I'll tell you some things later on, some things later on. At the end, it makes sense. So give it time. You will understand the entire. You will come a full circle. Okay, just give it time. All right. So now you understood the basic terminologies that they use in geomorphology. Before we get into rocks, I'll discuss another few terminologies that keeps coming up. Okay, folds, fracture, joints, faults, fissure, okay, shear zone. No, shear is enough. Okay. All right. So these are also some terms that you keep coming across in your geographical literature. You should just have an idea of this. There is not necessary that you go into the depth, but you just have to know folds. Okay, fold is, if I take, let us say, take some this thing. See, if I take this, okay. Now, before this, let me say there are two types of forces. Okay, there are two types of forces. All right, one is compressional forces. Another is tensional forces. Okay, one is compressional forces, another is tensional forces. Okay. Now, if two force, how is this force coming? Don't worry now. Okay, that is when you will jump different things. Just know one step at a time. Okay. If there are two forces converging, coming towards each other, they are known as compressional forces. If there are two forces pulling away, okay, if there are two forces pulling away from one another, then it is known as tensional forces. Got it? This is very important. Compressional forces is two forces moving towards one another, converging. Tensional forces are two forces moving away from one another, pulling away from one another. Okay, they are tensional forces. Okay. Now, let us say that this is a flat land. Okay, this is an land with undulating topography. Okay. Now, for some reason, I start applying compressional forces. Okay, I start applying compressional forces. When I start applying compressional forces, this flat land folds like this. Okay, this is known as folds. Okay, this is known as folds. Got it? So, whenever there are, so what type of forces will result in folding of the land? The forces that results in folding of the land is compressional forces. Can tensional forces result in folding of the land? No. Okay, tensional forces cannot result in folding of the land. Okay, so whenever there is compressional forces, the land results in formation of crests. The land results in formation of crest. You know what is crest? Okay, the land results in formation of crests of higher and higher altitude. These are known as folds. Whenever there are compressional forces, the land forms higher and higher crests, okay, or the land forms crests of higher and higher altitude. These are known as folds. Okay. I hope you understood that. What are folds? Okay. Now if I take a fold, if I take the fold, these are the limbs of the fold. Okay. This is X, this is Y. These are the limbs of the fold. Okay. Now if the limbs, if I draw a line here, if I draw a line at the center, if X and Y are more or less mirroring one another, the limbs of the fold are more or less the same. If the limbs of the fold are more or less the same, they are known as symmetrical folds. Okay, if the limbs of the fold are more or less the same, they are known as symmetrical folds. I hope you are understanding that. Okay. Now, if I draw, if this is X and this is Y, X and Y are not similar. Okay, X and Y are not similar. Okay, they don't mirror one another. Such type of folds are known as asymmetrical. Asymmetrical folds. Okay. The next, if X, Y. Okay, if the two limbs of the fold are almost horizontal, are you seeing it? It is not completely horizontal, it is almost horizontal. Okay, it is almost horizontal. Okay, then it is known as overfold. Then it is known as overfold. Understand these terms. Okay, here the two limbs are mirroring one another. Similar here means, yeah, the slope, height, yes, exactly. Rohit, just check if it is working properly. Rohit, just check if it is working. It is working there, the live. Are they able to see the feed? Yeah, one second, I'll just I'll get it. Is it are you people able to see? There is no issues with the feed, right? Because in my laptop it kind of stopped. Rohit, it's working. It's working. Just check it here once. Okay. All right. So we'll continue. All right. What are limbs of fold? These are limbs. Okay. Why is it so confusing? X and Y are limbs. Okay. Now, whenever I say similar, obviously it means the shape. The shape can be the slope. The shape can be the points, whatever it may be. Okay. Now, if X and Y are mirroring one another, then it is symmetrical. If X and Y are not, okay, if X and Y are not, it is not mirroring one another. If I take slope gradient also, it is not mirroring. If I take the altitude also, it is not mirroring. Getting it? Now, the altitude is the highest point. So, if I take the highest point, X is actually at a much higher surface compared to Y. So, I hope you are understanding. Don't worry about those things. Just know the two limbs are not similar to one another. Then it becomes asymmetrical. Okay. Now, overfold is where the two limbs are almost horizontal. See, they are almost standing like this. If it becomes like this, it is horizontal. Okay. It is standing like this. They are almost horizontal. Hence, it is a overfold. Thank you, Rohit. Okay. It will not happen again, Allah. Fine. All right. Then the last is nappe. Okay. The last is nappe. That is when a fold rests on the adjacent land. when the fold, this is the fold, okay, it is resting on the adjacent land. Okay, it is resting on the adjacent land, it is known as nappe or naps, however they pronounce it. Okay, so these are different ways or different types of folds that you see. Now someone asked for an example. See, such examples can be found in Himalayas themselves. Himalayas is not one mountain running like this. It is group of mountain ranges together going. At some part of these mountain ranges it is symmetrical. For example, Greater Himalayas is symmetrical. At some parts it is overfolded, especially the overfolded part and nappe part are found in lesser Himalayas. Okay, so example as such you will get to know over a period of time, because now if I say Great Himalayas, Lesser Himalayas, it will not make any sense to you people. Okay, so these are the different types of fold. You can find all types of fold within a group of mountain ranges. Okay, what is it that decides symmetrical, asymmetrical, overfold or nappe is the compressional forces. Now if the compressional forces on either side are almost the same, right, then it usually becomes symmetrical fold. Okay, now if let us say this side is very high, compressional force is very high compared to this side, then this starts pushing. Okay, this starts pushing. Okay, so the fold starts, you know, it starts becoming asymmetrical, overfolded and nappe. Okay, so it all is dependent upon what type of forces are acting and how much of intensity of these forces are from where. Okay, so more or less that is what decides what type of fold it is. All right, so this is about fold. Now if this is the land, see, layman terms, this is a mountain, and what is this? This is a valley. Understand these things. This is a mountain, and this is a valley. One. The second is, in geographical terms, they call any type of depression as syncline, any type of rising, folding as anticline. These are some names given to it, syncline and anticline. Okay. Sir, the variation in compressional forces decides the type of fold. Yes, Soumya. Yes, it does. Okay. Taking a nap on the, yes, you can say that. Fine, good. A recumbent is almost between this and this. Okay, recumbent, overfold is almost the same. Some people use the term recumbent for overfold, it is more or less the same. Okay, good. You can say that, HV, no issues. Okay. Direction will more or less be the same, okay, because compressional forces means two forces should converge. Okay, it is the magnitude. If the intensity here or magnitude is greater here, so it pushes more. Okay, so you will get it. Eurasian plate is not putting that much of compressional force, but Indian plate is putting. Okay, that is why the Himalayas are having all different types of folds. You will get that. Now if I tell, it doesn't make sense. So when the time comes, I'll let you know. Yes, Akshat, Himalayas are fold mountains. Okay, so we'll continue. So this is about folds, anticlines, synclines. Okay, understand these terms. Whenever I use the term syncline, you should know it is a depression. It's a valley type of a landform. Don't get confused. Okay. The next is these terms. Okay, in this, what is this? Okay, these two terms are similar. They are used in different this thing. American school of thought will use one, the European school of thought will use another, but it more or less means nappe is nothing. A fold okay, a fold which goes on to rest, okay, this fold is resting on the surface of another adjacent land, okay, this is a nappe, okay, fine. Anticline is formed due to compressional force, then how syncline is formed? Next, you will get to know all those things next, okay. Focus here. Now fracture and joints, okay. Fracture, see, if I take a particular rock, or let us say if I take a particular, let us say this is a glass, okay, it is a glass. Now on this glass, if I throw a small stone, okay, on this glass if I throw a small stone, what happens? The glass cracks, okay, the glass has cracked, okay. So in geography, whenever they use the term fracture or joint, it means cracks, okay. So understand, joints or fractures are nothing but cracks on the surface of the rocks, okay, they are nothing but cracks cracks on the surface of the rocks, okay, that is one. Now when I say a rock is well jointed, when I say a rock is well jointed rock, it means the rock has very good network of cracks, okay. It means whenever I say a rock is well jointed rock, it means that particular rock has very good network of cracks, okay. Now a fracture or a joint will evolve to become what we call as fault. A fracture or a joint will evolve into what we call as faults. So what is a fault? Okay, I hope the diagrams are making sense. This is A, this is B, okay. Now see, this is a pavement is a huge rock, okay. Now this pavement, for some reason in this pavement, okay, in this pavement, what have I done? That pavement was there. Now I have created a crack in that pavement. Crack means there is a joint, okay, or there is a fracture, alright. Now the pavement is fractured or the pavement is jointed, okay. Now whenever there is vertical displacement along the joint or a fracture, it becomes a fault, okay. This is a fracture or a joint, okay. Whenever, I hope it's making sense to you people, okay. See, this part has gone down, this part has, this is let us say y, this is let us say x, y, okay. So you are seeing one, there is a joint or a fracture which is nothing but a crack. Now let us say that this is one land, so I created a fracture in between, so that one land is there is a crack in between that land, okay. Now that crack is known as fracture or a fault, fracture or a joint. Now along the fracture or a joint there is vertical displacement. There is vertical displacement. It can be like this also, it can be like this also. In the diagram I have shown it like this. So if along the joint or a fracture, if there is vertical displacement, okay, it can be like this, it can be like this. Along the fracture or a joint, whenever there is vertical displacement, that displacement creates what is known as a fault. Okay, so a fracture or a joint can become a fault if there is vertical displacement along it. Okay, so this is a fault. See, I will tell you what, this is the fault plane. This is a fault plane, is a plane along which the displacement happens. Okay, fault plane is the plane along which the displacement happens. Okay, so I hope you can visualize it. So you can see the x has gone down, the y has gone down, sorry, not x, the y has gone down, x has remained where it is, hence this fracture has gone on to become a fault. Sure, I'll use the dark color, but either ways I keep telling the names of it anyways, so okay. Okay, so this is fault. All right, now before we move into fissure and shear, these are very easy. Okay, let us finish off this. So now a fracture or a joint has evolved to become a fault. Okay, now let us say that this this was the land. Let us say that this is the land. Okay, so I told you, let us assume that along this part there is a fault. Okay, along this part there is a fault. So this thing has come down. Okay, so I hope you can visualize it. In very simple terms, I'll tell you. See, if this is Indian Peninsula, okay, if this is Indian Peninsula, let us say that this was the fault. Let us say this is a fault. If the fault runs for greater distances, if this fault, okay, this fault let us say ran for just 100 meters, or let us say it ran for just 200 meters, then it is just a fault like this. Now this fault, that displacement started happening over longer distances for several kilometers together. Okay, if the fault happens for several kilometers together, then this fault goes on to become a fissure. Okay, this fault goes on to become a fissure. Okay, so I hope you are understanding. So this fault, okay, what I try to show here is, here the fault was up to this point, okay, then it started moving like this. The fault became more exaggerated. Okay, the fault became more exaggerated, then the fault turns into a fissure. Okay, a fault turns into a fissure. Okay, next, fissure in geography they also call something called shear zone. Okay, shear will give a different meaning, so let us use shear zone. So we started with just one crack. That crack, whenever there is vertical displacement, it became a fault. That displacement running for several kilometers together is known as a fissure. Okay, now what is this shear zone? Shear zone is nothing but a good network of faults and fissures. If there is a good network, okay, if there is a good network, see, faults are there, fissures are there. Okay, if the region has a good network of faults and fissures, then this region is known as shear zone. Okay, this region is known as shear zone. Okay, plane along which displacement happens, okay, is fault plane. All right. So these are some basic terminologies. Fault is not yet done. I hope you understood this. Okay. Make a note of everything properly. These will not be explained in layman terms even in internet. Okay, they make a very complicated definitions of this. So understand this clearly. Okay. A, this is B, and this is C. Okay, this is X, this is Y. All right. Can you please repeat fissure? A fault that runs for very long distances, several kilometers together, is known as a fissure. Okay. Examples, if I tell you now, it will not make sense. Okay. So if I just tell you flood basaltic fissures formed when Indian plate moved over reunion hotspot, it completely is Greek and Latin to you now. Okay. So wait for it once I come to those concepts. Shear zone is nothing but, see, if there is a good network, when I say network, there are different things that are connected to one another. If there is a good network of fissures and faults, okay, if there are good networks of fissures and faults, it is known as shear zone. The reason why they call it shear zone is, in shear, you have people who have done, mechanical engineering or, they have studied about physics or geophysics. You people know stress and strain, right? Stress is the cause, strain is the effect. All those things are not needed. Shear is where two movements are happening in opposite direction. If these are two blocks, if I move one block front and another block back, if I keep doing this, okay, this part is experiencing shear. Okay. So when a particular land is experiencing that, two blocks moving in opposite direction, a land will develop fissures and faults. Okay. So shear zone is a zone where you have a good network of both fissures and faults together. Okay. So there is a place called Singhbhum in Jharkhand. There is a shear zone there. Okay, you will not know those places, you will anyway come across those names once you are done with all the geographical part. Okay, and once you revise things, it will make sense to you. I know that you are, you want just to make a note of that example there just for the sake of it, but if I keep adding example for every basic term, if I keep telling, then it becomes an headache right now for you. Okay, so I will tell the names when and when the concept comes, and then you can add on to this. Okay. Is a fault formed over a plain or a plateau? It doesn't matter, it can form anywhere. Okay. A region with a good network of, yeah. Sir, does shear zone contain? Yes, it does. It does. I have written here, no? This is a fissure from year to year which is it running. The small ones are the faults. How exactly do you define good network? Well, good network means it has very high levels of, see, how did I define good network of joints? Good network of joint means there are high levels of cracks, okay, and each cracks are interconnected with one another is good network. Okay. See, plate movement, don't get there, Praveen, don't move it there. Okay, understand this term. We'll get there when the time comes. What is C diagram? Yes. Now, see, this is A. Everyone knows what is A, right? A is this. I explained how in A there is a fracture and how that fracture went on to become a fault. Okay. Now, first question is, in A it is a fracture, from A has it gone on to become a fault in C? Yes or no? Yes, it has gone on to become a fault in C, or no, C is not a fault. Tell me the answer. Okay. Manu, fault formed in surface of plates, the question itself doesn't make sense because you don't know what is the surface and what is the plate. Okay, wait for it until I finish. Okay, wait for it until I finish. Deepak, Romia, Shreyank, why are you telling it is a no? Okay, how is it? Navneet, how is it no? Basuraj, no. Why is it no? Okay, visualize this. Okay, this is, there are two blocks X and Y. Okay, there are two blocks X and Y. Okay, in B, this diagram B, Y has gone down like this. Okay, so Y has gone down, hence the diagram is looking like that. So a fracture, once this displacement happens, is known as a fault. Okay, now look at C, look at A and then look at C. I told you what is a fault. A fault is vertical displacement along the joint is known as a fault. That vertical displacement can be like this, downwards, or it can also be upwards. Okay, it can be downwards or it can be upwards. So the diagram that I am showing you in C is the block is going upwards. The block is going upwards. So this part is moving upwards. So this fault plane that you can see this side, here it is on the other side. You cannot see it because it's not a three-dimensional diagram. But I hope you can visualize the fault plane here that you can see is on that side. Okay. So yes, X and Y is showing a fault. Okay, X and Y is showing a fault. Okay, and here Y has gone up, the vertical displacement is up, here the vertical displacement is down. That is the only difference. Okay. Now there are two terms that they use, footwall and hanging wall. Footwall and hanging wall. Okay. In internet they keep using different definitions to make a very complicated thing of this footwall and hanging wall. Very simple terms. What is footwall? In both the diagram B and C, whichever block has more or less remained with no displacement. Getting it? The block which does not move much is known as the footwall, and the block that does most of the moving is known as the hanging wall. So in both the diagram B and C, tell me which is the hanging wall. Pawan is telling both X, Y. Very good. Alright. So I think you people have understood the concept. Okay. Now next question is, what type of forces are responsible for C? What type of forces are responsible for B? Okay. No, I'll ask you one question so that you don't have to type more. Both is wrong. I mean, see, here hanging wall is Y, okay, that is doing most of the moving. Okay. Then don't ask me that silly question, sir, in that case X will not move only, no sir, how X will also move a little bit, no sir, don't ask such things. Okay, it is not school exam. I told you there will be some minimal movement of X, but majority of the movement is done by Y. Okay, so Y is the hanging wall, the x is the footwall in my diagram whatever I have illustrated. That is one. Okay. Now this, for this type of fault to form, okay, what type of forces are responsible? For C, what type of forces are responsible? Rohit, it went again. Rohit, it went again. It's okay, for now you correct it. Once I give a break, you can do the changes. Okay. Okay, see, this is a rock, okay, and this is a crack. This is a rock, this is a joint, okay. Now visualize, if I put compressional forces, this is x and let us say this is y, compressional forces let us say of this part is very high compared to this part. However, if this is x and this is y, there is a joint, I am putting compressional forces, what should be the end consequence? On the same joint, x and y, I am putting tensional forces, okay, I am putting tensional forces, what should be the case? So here this x and y, because of compressional forces, will go on to become like this, that is, see, y as pushed up above the x part. Here because of tensional forces, okay, y has fallen down compared to x, okay. So B, this is B, right, this diagram B is mainly formed due to which type of forces? Tensional forces. A is usually formed by which type of forces? Compressional forces, okay. A is formed by, no, C is formed by compressional forces and B is formed by tensional forces, okay. Now I will tell you, whenever a fault, remember this, whenever a fault is formed by tensional forces, whenever a fault is formed by tensional forces, it is known as normal fault. Whenever a fault is formed by tensional forces, it is known as normal fault. Whenever a fault is formed by compressional forces, it is known as reverse fault, okay. Whenever a fault is formed by compressional forces, it is normal fault. Whenever a fault is formed by, whenever a fault is formed by tensional forces, okay, whenever a fault is formed by tensional forces, it is known as normal fault. Whenever a fault is formed by compressional forces, it is known as reverse fault, okay. So this is about faults, fissures, joints, shears, everything. Soumya, which should be x? See, hanging wall does most of the movement. Understand this. Here y has gone down, so this is doing the movement. Here y has gone up. X cannot go like this. Okay, x is standing there. Y has thrusted upon x. Look like this. X is there itself. Because compressional forces are acting here and it is more, y thrusts upon x. So y is the one that is doing the movement. So this is hanging wall in this case, okay, and this is the hanging wall in this case, okay. Okay. Sir, from where the tensional and compressional forces originate? This is what I told, don't start. Okay. When the time comes, I will tell. If I tell you it comes from convectional currents, what is convectional current? If I tell you they come from core mantle boundary, what happens in core mantle boundary? Okay. If I tell you electromagnetic currents runs there, what is electromagnetic currents? Understand the basics first. Getting it? If I tell you plate tectonics, what will you do? You don't know what is a plate only. Correct? So give it time. It goes one level at a time. Okay. I will give you the information when I have explained the precursor for that information that you can comprehend. Okay. If you don't understand the precursor itself, there is no point of just telling you something. Very good. So Deepak has asked a good question. Mountains are formed because of fold or fault. Okay, that's a good question. We'll discuss that now. However, I think we have done with this. Okay, we are done with the faults. Okay, so I'll just answer that question that Deepak asked. See, a mountain is known as fold mountain. A mountain is known as fold mountain. Okay. Fold mountains are basically mountains that are formed when the land folds itself like this. Okay. What is the forces acting? The forces acting are compressional forces. The forces acting are compressional forces. Okay. So whenever the land folds, Himalayas is a fold mountain. Okay. Rockies in North America is a fold mountain. Andes in South America is a fold mountain. Okay. Alps in Europe is a fold mountain. Okay. What is a fold mountain? When there is a land, okay, and if compressional forces are acting on either side, and there is folding of the land, then it is known as fold mountains. Okay. Here the elevated part of the land is created by compressional forces. Okay. Now, as Deepak asked, mountains can also be formed by fault. Mountains can also be formed by fault. They are known as block mountains. Mountains can also be formed by faults. They are known as block mountains. For example, if this is the land, okay, and this is, what is this? These are joints. Okay, this is the land. This is one full land. Okay, these are the joints. Okay, I am telling joints, not faults. These are joints. Okay. Now there are tensional forces acting. There are tensional forces acting. Okay. These tensional forces that are acting will create or will evolve joint to become a fault. Correct? It will evolve joint to become a fault. So if these tensional forces are acting, let us say for millions of years, finally what happens? This, if this is A, this is B, this is C, A and C are being pulled apart. Okay. After let us say 10,000 years, this is how it becomes. Okay. What has happened? A and B are remaining here. I am sorry, A and C are remaining here, and B has sunk inside. C has fallen inside. Okay. This is B. I am sorry, B has fallen inside. Okay. Now, see, folding, because C has gone down, because C has subsided, A and C are giving the appearance of a mountain. Okay, because it is looking higher elevation compared to other things. This, see, in general, this is a mountain, this is a valley. Okay, a mountain, a valley. Okay, This is a mountain. All right. Can you see that this type of an appearance is happening here also? Okay. Here the the part which has not subsided is creating the appearance of mountains. The part that is subsided has created a depression. The depression is looking like a valley. The depression is looking like a valley. Okay. This valley, okay, this valley like appearance or the depression is in actual terms known as rift or graben. Okay, it is not actually a true valley. Okay, it is a rift valley. They call it a rift valley because a true valley like this, a depression is created, a true valley is created if the river has cut it like that. Okay, you will learn how a river cuts and all those things. Now it is not needed. But a true valley is when the river is cut, the depression between the mountain. Okay, this is not a true valley. This is a valley that is created or a depression that is created because this B became a fault and went down. It subsided. Okay, so because B subsided, this depression is looking like a valley, and the parts that stood, that did not move, the footwall, okay, the footwall will act as mountains. Okay, such are known as block mountains. So block mountains are basically formed by faults. Okay, so these are the two types. The third type is volcanic mountain. Okay, volcanic mountains. Okay, these are mountains that are formed by the solidification of magma. Okay, we'll learn that when the time comes. Now you just know volcanic mountains are formed by solidification of magma. Okay. After doing so much, Navneet, you are asking me faults and joints difference. Very good. Narmada Rift Valley. Okay, Narmada is a rift valley because Narmada river did not carve a depression there. Okay, it was not Narmada that created that U shape. There, the land subsided down because on this side and that side there were cracks. That cracks evolved to become faults, or there were joints. The joints evolved to become faults. Okay. How to know which part will subside, sir? See, that that is a work of a geologist. Don't worry about it. But they usually see there are different clues. Okay, there are different clues. It takes time to explain that, but the clues will give away which has moved and which is not. Okay, so let us say that this entire thing was made up of a type of rock called shale. Okay, this entire thing is made up of a rock called shale. This band of this land is made up of shale. So if I start exploring from here and go, I can see the continuity of shale. But suddenly once I come to this point, I am not seeing any shale here. Okay, so I know that something has gone down, something has subsided. So there are so many different clues. You don't want to know. I mean, you don't have to know. It is the job of a geologist. So it's okay. Narmada and Tapi are rift valleys. Okay, both Narmada and Tapi are rift valleys. Okay, so you are right there. Don't worry. East African Rift Valley. Good, correct, Karthik. So we'll get there. In plate tectonics, I'll talk about the East African Rift Valley. There we'll speak a little bit more. Okay. Yes, Rhine Valley is good. Orst Mountains is there. Okay, Black Forest. So that is also an example of block mountains. Okay. Sir, A and C moved horizontally due to tension and B subsided. So to be classified as hanging wall, the movement has to occur vertically only, not horizontally. So where is the horizontal movement? I am not understanding. A and B moved horizontally. Okay, this type of movement you are talking about. Okay, okay. This type of movement is not deciding whether it's hanging wall or a footwall. Okay, this type of movements. Okay, faults, vertical displacement. Hitesh, what will be the relief of football with respect to, the relief will be high relief, Hitesh. Okay, it will be high relief. Yeah, when I say high relief, it need not be Himalayas. Okay, the Satpuras is not same as Himalayas. Okay, so Western Ghats are not mountains at all. We will get there in Indian geography. Okay. Anyways, I think I have cleared most of the doubts. Others, I think you're digressing, or you're asking a little advanced topics that you have to wait to get to know. Okay, so this is about the basics. Okay, so we'll take a 15 minutes break, and we'll come back and start off with the topic called rocks. Okay, we'll start off with the topic called rocks. All right, 15 minutes. I'll start the class. It's 11:02. I'll start around 11:15. Okay. Yeah. So I'm sorry, I didn't tell that, right? So if this is the rift or graben, the uplying part A and C is known as HORST, Horst. Okay, this is known as HORST. Okay. All right. So this uplying part is known as Horst. The subsided part is known as graben. Okay. Some people also say Horst graben topography. Horst graben topography means there is a very big mountain and then the valley. So, okay, formed by faults. Okay, Horst and graben. Yeah, forget the football and hanging wall if it is so confusing. All right, don't make a big deal of it. Understand if you can, otherwise it is okay. All right, so this completes it. Take a 15 minutes break, and then you can we'll get back to the topic called rocks. 11:20. I'll start the class exactly at 11:20. Okay, so we'll start off. What is the topography of Bangalore? Bangalore is not dissected topography. Okay, it is not that irregular. It is you can say undulating, but it's a plateau. Okay, Bangalore is a plateau. You'll get to know. Okay, because Bangalore itself is a small plateau standing on another plateau. Okay, the Karnataka plateau. So you'll get to know that. So what are those? While we traveling in some rural places, we come across a series of hills. See, they can be folds or they can be accumulation of rocks also. Okay, so it can be both the cases. But yes, you can tell that they are also fold, but they are fold not to such greater extent. Okay, there are small folds. So if we apply compressional forces to ABC, then which is rift? See, usually rift valleys are you can tell like this. Okay, so I got your doubt. Okay, so let us say that what you are telling is, if this is the compressional forces, okay, this both A and B are pushing, so say A and C are pushing B, okay, so it goes on to become like this. Here nothing is going down, but B is being pushed up, thrust upon. B is being thrust upon A and C. Okay, so this looks like a Ost, and these two look like a rift or a graben. Okay. The compressional forces to exist, right? In the case, how we can relate tensional forces to fold mountains. See, Shreyang, don't overcomplicate yourself, because you don't know the origin and how things work. What you are telling overall is correct, okay, but where tensional forces and how tensional forces, somewhere where tensional forces are there, that means somewhere else there should be compressional forces. All those you will learn, later on. Anyways, is that same in the model on diagram B? Because anyways, okay, so we'll go to the next topic, rocks. The next topic is rocks. Okay, so what is the definition of rocks? All right, so rocks are assemblages. Rocks are assemblages of minerals. That is, there are different minerals that you can find. Okay, all these minerals will come and sit in one common place, and this assemblage of minerals is nothing but rocks. Okay, so I can define rocks as assemblage of minerals. Okay, so the next question is, then what are minerals? Okay, then what are minerals? Okay, so minerals are naturally occurring inorganic elements. They are naturally occurring inorganic elements. Okay, so these minerals which are naturally occurring inorganic elements, okay, these minerals, they usually will solidify. Okay, they usually will solidify. Okay, they solidify and then they come and join together to form what we know as rocks. Okay, so I'll repeat again. Rocks are nothing but assemblages of minerals, and minerals are naturally occurring inorganic elements. Okay, example for minerals is silica, alumina, okay, manganese, okay, iron, nickel, okay, all these are minerals. Okay, so these minerals, they can have different phases. Okay, these minerals can have different phases. Okay, that is, the minerals can be liquid, the minerals can be solid too, depending upon the temperature. Okay, however, the minerals, whenever they transform into solid, okay, at whatever temperature it is, the mineral, when it transforms from liquid phase to the solid phase, it is known as crystals. Okay, in solid phase, they are known as crystals. Okay, in solid phase, they are known as crystals. okay, and this group of crystals of different minerals, the group of crystals of different minerals will form what we know as rocks. Okay, the group of minerals which take the form of crystals, they together will assemblage, that is different minerals of their solid forms will come together to form a big collection of minerals that are known as rocks. Okay. Now, why is it that once they become solid, the minerals are called crystals? The reason is, it is called crystal because a particular mineral will take a particular solid form. Okay, a particular mineral can take a particular solid form. Okay, and it also has a particular or a specific chemical and physical properties associated with it. I hope you understood. It is called crystals because the shape that a mineral takes. Okay, for example, if silica takes a shape of, let us say, a shape like this. Okay, if silica takes a shape like this, then everywhere on earth silica will always take a shape like this. Okay, so they are called crystals because it takes upon definite shape. A particular mineral will take upon a definite shape. To a particular mineral will have its own particular physical and chemical properties. Okay, it will have its own unique physical and chemical properties. It will take its own unique shape. Because these two reasons are there, they are known as crystals. Okay, so I hope you understood. We have minerals like silica, alumina, magnesium, manganese, iron, nickel. We have different minerals. These minerals can go on to take solid form, which are known as crystals. That crystal can all come together to form a collection of crystals to form rocks. So rocks, at a very simple terms, is known as assemblage of minerals. This is how rocks are formed. All right. Now, sir, what is the shape that different minerals take, and what are the what are the chemical and physical properties of different minerals? Goes off into again geology, not even geography. Okay, it goes off into a specific part of geology known as geochemistry, which is not relevant for you people. So don't break your head on that. Okay, you should know what are crystals, what is minerals. Okay, that's all the basic aspects of it. Okay, so now you learnt what is a normal term, or what normally is a rock. Okay, now usually there are three types of rocks. Not usually, there are only three types of rocks. Sorry for that. There are three types of rocks. If this red is not visible, let me know. I'll change the ink. Let me write it in black. I thought red will be more visible. So igneous, sedimentary, metamorphic. Okay, there are three types of rocks: igneous, sedimentary, and metamorphic. Okay, so I told you, at the end of the day, rocks are nothing but minerals. This minerals changes their phase from liquid to solid. Okay, and when they are changing their phase from liquid to solid, they are becoming crystals, and these crystals together assemblage to form rocks. So why am I starting with the term liquid to solid? Why am I using that? Why should there be liquid to solid? Because at the end of the day, a first rock, let us say the first types of rocks, okay, if I have to take the source for the first rock that is ever formed on earth, okay, that starts from where? What is rock at the end of the day? Rock, at a very layman term, that is a rock, its very primary source, that is the first type of that particular rock that you can trace back to. The source is igneous rocks. Okay, so igneous rocks are also known as primary rocks. Okay, igneous rocks are also known as primary rocks. Okay. Now, as the term igneous, the igni comes from a word called agni, okay, which means fire, right. So, igneous rocks are basically coming from what we know as magma. Okay. So, I hope you people know what is magma. In the interior of the earth, okay, because of high temperature, the rocks at some places are melted. I hope you are understanding. Ice melts, correct? If I increase the temperature, ice melts. From solid it becomes liquid. In the same way, in the interiors of the earth, because there is increase in temperature, correct? So, at some places, I am not using at all the places, at some places the rock melts. Okay? This melted form of a rock, okay, this melted form of a rock is nothing but magma. Okay? So, the igneous rocks are the first rocks to be formed, okay, and from where are they forming? They are forming because of solidification of this molten form of a rock. Okay, igneous rocks are the first type of rocks to be formed. One, okay, they are formed from this molten form of a rock which is known as a magma. Okay, when this magma cools down, from liquid phase all the minerals will start becoming solid. From liquid phase these minerals will take the shape of crystals, okay, and this will join together to form a rock. That type of rock is known as igneous rock. Okay. Now see, so let us say that this is the core, okay, this is the crust, okay, this is the core and this is the crust. Okay. Now we know that the magma moves in the interiors. It can sometimes come out to the surface also. It can come to the surface also. At the basic level, you people understood what is a magma. Magma is molten rock. Rock that is in its liquid state is known as magma. Okay. Now, if that rock that is in its liquid state or the molten rock, in the interiors the molten rock is known as magma. Once it comes out of the surface, the same molten rock is known as lava. Okay, understand the difference. So, igneous rocks can be formed by the solidification of magma or the solidification of lava. Okay, that is the point. Next. Okay. So, there are two types of igneous rocks. One is extrusive rocks, two is intrusive or plutonic rocks. Intrusive or plutonic rocks. Okay. Two types of igneous rocks are there. One is extrusive, another is intrusive. All right. All right. So, what are extrusive rocks? Okay, extrusive rocks are formed from solidification of lava. Okay, that is the molten rock in the interiors of the earth have come out, have erupted out, and then they have cooled down to form a solid known as extrusive rocks. Okay. Intrusive or plutonic rocks are solidification of magma. Okay. So, if I take this as the surface and if I take this as the core, now at some place the magma has erupted out and this has cooled down. So, this has become extrusive. At some places, it didn't come out, it cooled down here itself in the interiors of the earth. This is known as plutonic or intrusive rocks. That is the main difference. Okay. So, extrusive is formed by the solidification of lava. Plutonic is formed because of the solidification of magma. First. Second point. Now, if you take extrusive or intrusive, alright, if you take extrusive or intrusive, where do you think cooling is faster? That is, Cooling is faster, so solidifying is faster. Where? Is it extrusive or is it intrusive? Tell me. Very good, very good, very good. So you people are right. So the cooling, or in other terms solidification, is much faster in extrusive rocks compared to intrusive rocks. Okay. Now tell me, if that is the case, coarser crystals, okay, coarser crystals can form in extrusive or intrusive. Coarser crystals can form in extrusive or intrusive. Okay. Think about it. At some place the cooling is faster, at some place the cooling is slower. Okay. Coarser crystal will form where cooling is faster, or coarser crystal will form where cooling is slower. Think about it. Okay. Now, should I give more time for the crystal to become larger, or should I give less time for the crystal to become larger? Common sense. Okay. For the crystal to grow large, that is, it will take for example, silica is taking more and more silica and the crystal is becoming more and more large, correct. Now for that mineral crystal to become more and more large, it needs more time. Okay. Now for the crystal to be very fine, it's very less, the crystals are fine if the time is less. Okay. Now in extrusive and intrusive, if you take, in extrusive the cooling is faster. Why? Because magma is exposed to the atmosphere. When it is exposed to the atmosphere, it cools down faster. Whereas if you take magma in plutonic, this magma is within the interior, so it is not exposed. The loss of heat is not so high. Okay. As someone had told, it conducts very well. Yes, it conducts, but it is not as faster as radiating the heat. Though once the magma comes out and becomes lava, it releases heat very quickly. Here it is just conducting. Okay. So because extrusive rocks are releasing heat very quickly, and because cooling is faster, what type of crystal should be here? The rocks will have fine crystals, because you don't give it time to grow. The crystals are very fine. Okay. In intrusive rocks, because the cooling is very slow, the loss of heat is low, the crystals can grow and become more and more larger, and hence it is known as coarser crystals. Okay. So it is logical, don't bayard things. Okay. So one, extrusive rocks is because of lava, intrusive rocks is because of magma. Extrusive rocks has finer crystals, okay, finer crystals. Intrusive rocks will have coarser crystals. Okay, intrusive rocks will have coarser crystals. Okay. This coarser or finer depends upon the rate of cooling. Okay. Here intrusive rocks rate of cooling is very low, hence crystals will become coarser. Extrusive mein rate of cooling is high to very high. Okay, it is high to very high. Rate of cooling is high to very high. High give rise to finer crystals, very high gives rise to very fine crystals, or glassy appearance. Okay, very high, very fine crystals or glassy You know glass. In glass, can you find any difference in the shape? It all looks uniform. Okay. In the same way, the rock itself looks like a glass. Okay. Why the rock looks like a glass? Because the crystals are so fine. The crystals are so fine and small, your naked eyes cannot recognize those crystals. So overall, it is looking like a glassy appearance. Okay. Why is it so fine? Why is it that you cannot make out, you have to use a microscope to see the crystals, you cannot see through your naked eye. Why is it so fine? Because the rate of cooling was very high. In geological terms, they call it quenching. Okay, they call it quenching, 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 but that's not required for you. Whenever it is very high, the cooling is very high, it becomes glassy appearance. Whenever the cooling is high, it is fine crystals. Okay, whenever the cooling is slow, it is coarser crystals, but these coarser crystals are very specific to intrusive rocks or plutonic rocks. Okay. So now I'll tell you the names. Obviously you people are sitting there at your house, you can just Google those names and look at the crystals. Okay. First is I will tell you about intrusive. Okay, first I'll tell you about intrusive so that you see intrusive rocks. Okay. Example for intrusive rock is granite. Example for intrusive rock is granite. Okay, look at granite. Look at granite. Example for intrusive rock again is gabbro. Okay, you can just Google it and look at the images of it. Okay, look at gabbro. If you see texture, when I say texture, in geography, texture means the skin. So if you see the texture of granite and gabbro, it is very rough. The texture of intrusive rock is rough. The texture of extrusive rock is smooth. The texture of intrusive rock is rough because of coarser crystals. Okay. The texture of extrusive rock is very smooth because of finer crystals. Okay. Now, see if you look at the granite, you can see okay, you can see different gray, dark gray, light gray, so many different things. So though they are all big crystals coming together. Okay, granite, gabbro are examples of coarser crystals. Now extrusive, I told you, is finer crystals. Okay, here I'll first look at this rock. Look at a rock called obsidian. Okay, you can look at a rock called obsidian rock. Okay, if you just Google and look at the image of obsidian rock. Okay, obsidian rock is smooth, glassy appearance. If you see, it is looking like a well polished rock. Okay, can you see any type of specks there? There is nothing. There is no irregularity at all. It is completely smooth. Okay, obsidian rocks. Why? Because the lava cooled very high, cooled at a very high rate. There was no time for the crystals to grow. The crystal is very microscopically small. Okay, so they are obsidian rocks. They are a type of extrusive rocks. Okay, other rocks of extrusive rocks are, other important extrusive rocks are basalt. Other important extrusive rocks are basalt and rhyolite. Okay, I'll write it here. Other extrusive rocks. These are of finer other extrusive rocks are basalt and rhyolite. Okay. If intrusive rocks happens middle of the ocean. See, oceans are on the surface. Intrusive is below the ocean is standing. Ocean is standing on the crust. Ocean is not below the crust. Okay. So intrusive rocks are there below the crust. Oceans are here. Intrusive rocks are here. Okay. So don't think it's okay. Next topic is interior of the earth. It will make more sense. All right. pressure determines coarse or fine, Deepak, I will not tell it predominantly does, but it has a role to play, definitely. Okay, it will have a role to play. As I told you, temperature and pressure are inversely correlated, so you can put that as a this thing. Scoria is rough. Scoria is a very who asked that question? See, that is the problem. You will ask something, other people will start getting perplexed. Sir, I don't know what is scoria. I think I am not competent. I think my preparation and all those things. So don't worry about those things. Okay, scoria is a very special type of extrusive rocks. Okay, if you see scoria, it will be in your bathrooms. Okay, if you see a very light rock, that rock, for example, if you Google pumice, Google this rock called pumice. Okay, this rock is nothing but rock that has a lot of pores, P-O-R-E-S, pores, wide spaces, empty spaces. That rock is so light. That it can float on water also. Okay, scoria is a type of pumice only. Okay, whatever it is a type of extrusive rock. The reason why it has so much empty spaces is once the magma comes out as lava, there will be some part of magma or lava which is predominantly having gas. Okay, let us say it had predominantly gas. So once that magma comes out as lava which has lot of gases in it, so once it comes out, all the gases will escape very fast. Before cooling only it will escape and then it will cool. So once it escapes and then it cools, the positions held by the gases within the rock or magma are empty spaces now. Okay, that is why you will see that empty spaces in the rock. It again goes off into not necessary. These are all unnecessary for GS. Okay, so yes, Sakshi, food scrubber, something like that you can say. How do we fetch intrusive rocks? You don't have to fetch. If you learn plate tectonics, you will know how intrusive rocks over a period of million years has high chances of coming outside. Okay, you will learn that, don't worry. Pumice stone is used. Yes, Yogesh, that is what is this thing. Anyways, Deccan Plateau can be an example of extrusive rocks. Deccan Plateau, yes, you can. Deccan Plateau is an entire plateau formed. It is a volcanic plateau. Okay, so the entire plateau is formed by lava. Okay, so obviously the rocks within that is extrusive volcanic rocks. Okay, fine. So this is about igneous rocks. Another thing that you should know is igneous rocks are non-fossiliferous. Igneous rocks are non-fossiliferous. Igneous rocks are non-fossiliferous rocks. Okay, non-fossiliferous rocks. Now, what is fossil? What is a fossil? A fossil, remember properly, very simple terms, a fossil is ancient remains of an organism. That organism can be animal or a plant, doesn't matter, but that organism should be biotic, that organism should be organic. Okay, so fossils, if I have to define fossils, fossils are ancient remains of an organism, is known as fossils. Okay, now if I take igneous rocks, okay, I told you they are non-fossiliferous, that is, you cannot find any type of ancient remains in these type of rocks. What is the reason? What is the reason? The reason is because these rocks are formed at very high temperatures. The magma will be around 1200 to 1800 degrees centigrade. Okay, at that high temperature, no remains of an organism can survive. Hence, igneous rocks are non-fossiliferous rocks. Okay, good. Now, next question is, can petroleum be found in igneous rocks? Can petroleum be found in igneous rocks? Very good. Fine. So for people who are facing confusion, petroleum is a type of fossil fuel. Okay. Petroleum is a type of fossil fuel. Natural gas is a type of fossil fuel. Even coal, whatever they burn to in thermal power plants, the coal is also a type of fossil fuel. Why they call it fossil fuel? Because it is a fuel obtained from a fossil. Okay, it is a fuel that is obtained from a fossil. A fossil of plant remains creates coal. Okay, a fossil of aquatic animal remains creates petroleum. Okay, I hope you are understanding. Fossil fuel is because a fuel is derived from a fossil. If that fossil from which the fuel is derived is an ancient vegetation or an ancient remains of plants, then it is known as coal. If that fossil fuel, the fossil is an aquatic, ancient aquatic organism, okay, or ancient aquatic animal, then it is petroleum. I hope this much is clear, I mean is enough for now. Okay. So because fossil fuels are nothing but fossils at the end of the day, and there is no fossils, so obviously there cannot be any type of fossil fuels also that can be formed. Alright, so non-fossiliferous, hence you cannot find petroleum, coal, natural gas, nothing can be found in the igneous rocks. Okay. The next this thing, igneous rocks are the most mineral rich rocks on earth. Okay, I am not asking you, I am telling you. Igneous rocks are the most mineral rich rocks on earth. Okay, they are the most mineral rich rocks on earth. Okay, why? Because see, they are basically coming from the interiors. Okay, from the interiors they are bringing minerals in liquid state to the upper surface, and then they are erupting. So in the interiors the layers are rich in minerals. Once they come out, they are bringing those rich minerals to the surface. Okay, so very rich they are with respect to different minerals. Even in India, wherever you are taking, you are seeing the minerals that are being mined, most of them are igneous rocks. Okay. So petroleum reserves can be found in oceans only. Yes, Prakar, that is correct. Petroleum reserves can be found in oceans only, but oceans are not a static entity. Over a period of time you will learn, oceans, where there was ocean need not be an ocean today. Where there is ocean today need not be an ocean million years after. Okay. So today in Assam there is a place called Digboy. Okay, there is a place called Digboy, you find petroleum there. Okay. That does not mean today there is an ocean there. It means there was an ocean several million years before. So one, petroleum can be found on oceanic bed. That oceanic bed today may be prevailing or not prevailing, does not matter, but at one point of time there would have been an oceanic bed, and only then can you find petroleum there. Okay. Anything be done to improve the mineral levels to a high? Dhananjay, I didn't understand the question. What do you mean by high? Because in mining now there are several terms that have come called mineral beneficiation. So these technologies they use to increase the concentration of minerals within a particular ore. So they have done those things. So I don't understand the question properly. But anyways, either ways it is again digressing from the topic. What about the rare metals? They should not exist then because of temperature. What? See, the problem is, Akshat, when you say rare metals, is it rare earth metals? Are you talking about lanthanides, yttrium? Are you talking about metals that are rare? Because rare metals are not, rare earth metals are not rare. Okay, so I don't understand the questions when you are asking. Dhananjay, high meaning no dearth of minerals. Can anything be done to improve the mineral levels to? That is a relative question, Dhananjay. Okay. Anyways, we are moving away from the topic now. We will come back to this. Okay. So we are done with igneous rocks. Okay. Next is sedimentary rocks. So Middle East was an ocean bed long time ago, 100%. See, it is very natural. Okay, I'll tell you how later on. Petroleum basically happens because you need very good sites of deposition. Oceans are sites of deposition. Okay, so when the organism dies, it goes down the ocean. Okay, as you go down the ocean, the temperature decreases. Okay, so the body is preserved. Okay, now on this top of body, sediments gets covered, so burial happens. So petroleum can form only if this process works. You will learn it later, but you should know West Asia, wherever you are finding today petroleum, it is always a erstwhile ocean. That is, there was an ocean before. Anyways, coming back to sedimentary rocks. Sedimentary rocks. Okay. So sedimentary rocks are made by the assemblage of sediments. Okay, it is made by the assemblage of sediments. Okay, it is made by the assemblage of sediments. Understand this. Okay. Now, what are sediments? Sediments are nothing but group of small stones of different sizes. Okay, sediments can be group of stones. I am using stones. Stones means smaller size. Rocks means huge. They are nothing but group of stones of different sizes. Okay, so the sizes varies like this. Okay, it can be mud, silt, sand, gravel, cobble, boulder. Okay, so size increases. Okay, this is 264 mm. to 264 mm, 4 to 2 mm. Okay, sand is 2 mm. One second, I forgot this fact. 2 mm, 2 mm to 1/16th of an mm. Okay, this is 1/16th mm to 1/256 mm. This is less than 1/256 mm. Okay, you don't have to remember these numbers. These numbers are not, they will not ask you these things, but you should know what they keep using these terms: sand, silt. Okay, this is known as clay or mud. Okay, clay or mud. Alright, so whenever they use the term sand, understand that they are sediments of relatively higher size than silt, relatively lower size than gravel. Okay. If you want to have a rough idea, gravel means they mainly use small stones in constructions. Okay, they usually use that as a raw material to put into the cement. Okay, those rocks, I don't know what they call it in this thing. In our language here in Karnataka, they call jelly kallu. Okay, they break it into small. They take a huge rock and break it into small pieces. Okay, that small pieces you can visualize as gravel. Just Google it, you will find it. Okay, sand. Anyway, you can visualize sand, coastal sand. Okay, that sand is 2 mm to 1/16th of an mm. Lesser sizes than sand is silt. Even much lesser size than silt is clay or mud. Okay, so this is nothing but different sediments of different sizes. Sediments of different sizes. Okay, so at the end of the day, sedimentary rocks are rocks that are made by the assemblage of cobbles and pebbles more or less come here itself. Okay, cobbles and pebbles more or less come here. Okay, what was I telling? There are clastic sediments. Yeah, you people are using so much different knowledge. Forget everything, erase everything and listen properly. Okay, don't go into clastic, non-clastic, all those things. It is fine. I know that you people have studied those things and come. It is good. But erase your mind and just listen, carefully first. Now, sedimentary rocks are basically made from sediments. Okay, they are nothing but assemblage of different sizes of sediments. The sizes of sediments can vary. It can go from clay, which is the minutest, and then rise up to boulders. Okay, sediments can be clay, silt, sand, gravel, cobbles or pebbles, and boulders. Okay, so this is more or less the sediments and the group of sediments. Okay, so I told you sedimentary rocks are formed by the assemblage of this. Okay, so in one sedimentary rock, it is not necessary that everything should be clay, or in one sedimentary rock, it is not necessary that everything should be a boulder. Okay, it can be a mix of boulder, cobble, it can be a mix of boulder, mud, silt, whatever it can be. There can be a mix of anything. Okay, understand that. All right, next. How is it formed? The sedimentary rocks, how are igneous rocks were formed because of solidification of magma. Okay, igneous rocks are formed because of solidification of magma. Sedimentary rocks are formed because of these two processes, burial and lithification. They are formed because of these two processes, that is burial and lithification. Okay, what is burial and lithification? Let us have a look now. This is the mountain. Okay, this is, let us say, the oceans. I told you oceans are what? Excellent sites of deposition. Oceans are excellent sites of deposition. Okay. Now, we are speaking about a hypothetical scenario. Let us assume this was a rock. Okay, this is a rock. One rock I have taken. Okay, I am allowing this rock to stay there for 10,000 years. Obviously, the rock that is there for 10,000 years will start breaking down. Okay. Now, the rock breaks down into several smaller pieces because of a process called weathering. Okay. For you now, understand, weathering means rocks breaking into smaller fragments. Now, because weathering is a separate topic that you will learn more in depth, now to understand this, we are not doing weathering. So, for now understand that this rock A has undergone weathering. That means what? This rock A has broken into small pieces. Okay. Now, this rock A that is broken into small pieces, the river flows from this point and it reaches the ocean. I told you the river's job is to reach the ocean. Now, the river that is moving will obviously not keep quiet. It will carry the sediment, broken sediments, and come and deposit in the oceans. Okay. So, what has happened? The rock A that was broken down into small fragments, those smaller fragments are carried by the river and brought into the sites of deposition. Okay, brought into the sites of deposition and are deposited there. Okay, right. Now, obviously I took just one rock. I will take another rock. The next rock is B. Obviously, in the mountains you will not find only one rock. You will find so many different rocks, right? So I am hypothetically talking. Now I will take another rock. This rock is B. Again, this rock undergoes weathering. I am talking over a course of 10,000 years, 1 million years. It does not happen in just few days. Okay, rock B has undergone weathering. Now, same, the B is taken down. Now the B is deposited. Okay, now here B is deposited. I hope you are following. Look and observe sites of deposition. The sites of deposition, two things are happening. One is burial. Okay, why is burial happening? See, in this site of deposition, first rocks came, sediments came. Okay, then came the next sediments. Okay, then came the next sediments. Like that, if I keep allowing more and more sediments to keep depositing, what is happening to this? This is undergoing what we call as burial. So burial is when successive layers of sediments keep blanketing over it. Okay, when successive layers of sediments keep covering the original or the first sediments, then it is known as burial. Okay, now this is the first step. The second step is this. Okay, lithification. Lithification is nothing but two things. Lithification is nothing but compaction and cementation. Okay, lithification is nothing but compaction and cementation. Where to cover these topics from? I will tell you to cover where to cover these topics from. Obviously everything is there in NCERT, but not only in NCERT but geography, anywhere they will not give you full clarity. Okay, so please listen to the classes properly. Okay. Vinay says course aggregate 20 mm to 40 mm in construction, sir. Cool, no issues. I just gave you one way of visualizing things. Okay. We have Samparna telling clastic sediments. Clastic, guys, just means fragmented. Okay, clastic means fragmented. Okay. Do animal living on land do not form anything? No, they do not form anything. Okay. All right. Green ink is not visible, is it? Okay, I will not use it. Okay. All right. So we are, where are we? We were talking about sedimentary rocks. It is an assemblage of different types of sediments of different sizes. That is one. Okay. Redefining burial is nothing but if the overlying load keeps increasing, okay, then the original sediments are facing more and more pressure and it is undergoing burial. Okay, there is no defining part of it, its literal meaning. Burial means what? You bury by increasing the overlying load. You bury a body by putting it inside and then putting successive layers of sand on it. Okay, the same way first group of sediments is undergoing burial because the succeeding load on top of it is increasing. Simple. Okay. The next, after undergoing burial, this group of sediments, the bottommost group of sediments, after undergoing burial, it undergoes lithification. Okay, it undergoes lithification. Okay. What is lithification? It is nothing but compaction plus cementation. It is nothing but compaction and cementation. Now, what is this compaction and cementation? See, the rocks are like this. Okay, the rocks are like this. Now, if I keep increasing the amount of superlying load, that is the uplying load, super incumbent load, everything means the same. That means the load on top of this. If I keep increasing the load on top of this, obviously these sediments are facing more and more pressure. When they face more and more pressure, the grains will start decreasing in size because pressure is pushing it. Okay, this decrease in size of the grains or sediments is known as compaction. Okay, so the grains that are like this, as more and more burial takes place, as more and more successive layers of sediments accumulates on top of it, okay, results first in compaction. So this sediment will go on to become like this. Let us say after thousands of years, experiencing the burial and increasing pressure, goes on to become like this. Okay, it goes on to become like this. see the size of the grains have reduced. The size of the grains have reduced, first point. The second point, so lithification, one compaction is done. One compaction, you understood? Compaction is nothing but the reduction in size of the grains or the reduction in size of the sediments experienced because of the increasing pressure above. Next, cementation. Cementation is, see, because of the increasing pressure, okay, obviously with the pressure here the temperature also relatively increases. That is, as I add more and more layers, and go, the bottom layer will experience more and more pressure as well as temperature, okay, here, because of the load. Now, because of that, what happens, these different small sediments will start sticking with one another, okay, they start sticking, okay, they start sticking to one another. This is known as cementation, okay. So, once cementation is completed, this entire block will behave as one entity, that is known as sedimentary rocks, okay. So, to repeat the entire process, okay, of sedimentary rocks, first, sedimentary rocks are nothing but assemblages of sediments, okay. These sediments are coming from land. From land, you know, the sediments are being brought by the rivers and dumped into oceans, because oceans are the best sites of deposition, okay. At the sites of deposition, the sediments are undergoing burial. Successive layers of burial will give rise to something called lithification. Lithification is nothing but compaction plus cementation. Compaction is nothing but reduction of grain in size because of the increasing overlying pressure, and cementation is nothing but sticking of one grain to another, okay, sticking of one grain to another, so that all the grains conjoin, all the grains will join together to form one single entity called sedimentary rocks, okay. So, this is how sedimentary rocks are formed. Lithification is compaction plus cementation, okay. Burial mostly happens in oceans. Yes, Soumya, burial mostly happens in oceans, okay. Mostly because very rarely it happens in inland drainage, okay, like lakes near the oceans, but mostly it happens near the oceans, okay. So, this is sedimentary rocks. Sedimentary rocks will only find in oceans. See, sedimentary, you are only comparing today's oceans, okay. Today's oceans are not even 200 million years old, okay. Earth is 4.5 billion years old. So, what oceans you are, you know, obsessed about today's is a very young form compared to the old, you know, nature of the earth. There have been several oceans that have come, that have died, okay. So, don't keep you know, thinking oceans means only the oceans that are there today, getting it? Sir, denudation process and burial process are one and the same. Shivanand, tomorrow you will learn, tomorrow or day after you will learn denudation, okay. Denudation is a geomorphic process that involves weathering, mass movement, okay. It involves you know, erosion, transportation and deposition, okay. So, weathering, mass movement, erosion, transportation, deposition you are talking about. So, denudation is a lot of things. That is why I do not clear the doubts when you ask something, this thing, because so many things you do not know yet, okay. Sedimentary rocks are found inside the ocean only, yeah, okay, yes. Can sediments form from wind movements which carry fragments in it? It can, Vishwa, it can, okay. At the end of the day, whatever the sediments, it can be carried by wind or it can be carried by river or whatever it is, it has to be put in sites of deposition, and it has to undergo burial, and then it has to undergo lithification. Okay, so that happens over millions of years, then it can. Okay, the process of compaction itself, or are the result of greater cementation? Are boulders in the process of compaction itself, or are they result of greater cementation? No. Boulders as a result of compaction itself, they still remain. Some rocks will be very resistant to high pressures also, so they will remain that greater size. Okay, good, fine. All right. So sedimentary rocks is not yet done. So you understood the origin of sedimentary rocks. Okay, you understood the origin of sedimentary rocks. All right. There are three types of sedimentary rocks. Okay, there are three types of sedimentary rocks. All right. One, mechanically formed sedimentary rocks. Mechanically formed sedimentary rocks. Next, organically formed sedimentary rocks. Okay, the third is chemically formed sedimentary rocks. All right. So mechanically formed example is sandstone, siltstone, conglomerate. Okay, sandstone, siltstone and conglomerate. Organically formed is coal, limestone. Okay. Chemically formed is alite. It is nothing but NaCl. Okay, alite or NaCl. Even rock, yeah, we will, Soumya, it's a good question, we'll discuss. Every rock is, it comes always from igneous is the parent rock, right? So everything comes from the magma. Okay, there's something called rock cycle, you'll know the rock cycle later. Basalt and rhyolite are what you are asking that here now. Basalt and rhyolite are extrusive rocks. Okay. Yes, I'll get to fossils. Finish this. We'll get to fossils. Don't jump. Okay. One, shale. Shale also is an example. Okay. So here, one second. Here, mechanically formed sandstone means it is a stone that has lot of fragments of sand size. That's all. Siltstone. Siltstone means a lot of stone that is formed by silt size. Okay. Shale. Shale is a rock that is homogeneously formed by sediments of the size of clay. Okay, the size of clay. I hope it's making sense, the table now that I have given you. Okay. So conglomerate. Conglomerate basically are sizes of cobbles and above. Okay, it is group of fragments or sediments that are formed by cobbles and above. Okay, cobbles and above is conglomerate. Okay, so these are all mechanically formed. Okay. Organically formed sedimentary rocks is coal. I told you coal is nothing but instead of rock fragments, if I add ancient vegetation, okay, if I add ancient vegetation instead of rock fragments, imagine there were ancient vegetation that were buried. Even the ancient vegetation will undergo lithification to form coal. So coal is actually a type of organic sedimentary rock. Okay. Limestone, there are a lot of organisms in oceans, that secrete lime. Okay, they create lime, calcium carbonate shells of calcium carbonate. Okay, these shells will obviously break down into small parts, small sizes. They will also undergo burial, lithification, and then result in limestone. Okay. So coal and limestone are organically formed. Why they are organically formed? Because limestone has its origin with animals and coal has its origin with trees, ancient trees. They are put and organically formed sedimentary rocks. The next is alite. Alite is nothing but NaCl, salt NaCl. If you take ocean water, okay, and if you evaporate the water will evaporate, vaporize and go off. What is left behind is salt. Okay. Those salts can again compact together. Those salts can again compact together to form a rock. The salts can form one single entity called alite. Okay, it is nothing but NaCl coming together, and that alite is a chemically formed sedimentary rock. Okay, so in all the three, okay, irrespective of what the origin is, it has to come to the process of burial and lithification. Okay, so that is regarding sedimentary rocks. Okay, fine. I hope you people are jotting down the points, okay, because a lot of things, if you read from NCERT, there are disconnects. They don't give you that clarity, nor the internet will. So please make sure you make a note of it, everything. And don't have that habit of, I'll see the video later, I'll see the video again. It's a waste of time. Okay. Alright. So now coming to some characteristics of sedimentary rocks. First, in geography, whenever they use the term called stratified, or strata, okay, it means if I take this rock, the rock has several layers. Strata means layers. Okay, strata means layers. Okay, if a rock is composed of several layers, okay, then it is known as stratified rock. Okay, and sedimentary rocks are usually stratified rocks. Sedimentary rocks are usually stratified rocks. Now food for thought, how did they become stratified? Look at this diagram and look at this rock. Can you imagine how this rock went on to become stratified? If you can, that means you are good, you have got very good clarity of what the process is. Okay. Coming back, sedimentary rocks are stratified rocks. Stratified means layered rocks, one layer. So if I take one big sedimentary rock and examine it, I can find different layers. Okay, so that is one. Second, sedimentary rocks are fossiliferous rocks. Sedimentary rocks are fossiliferous rocks. Okay, sedimentary rocks are fossiliferous rocks. Sedimentary rocks are fossiliferous rocks. How? How can they be fossiliferous? When they are undergoing burial, okay, when they are undergoing burial, if let us say some fossil stuck here, some fossil got stuck here, okay, so that fossil will be remain, I mean that fossil, the ancient remains will be there, that ancient remain can go on to become a fuel, okay. So one, sedimentary rocks are fossiliferous, okay, because this, during the burial whatever fossils are trapped within the sediments are preserved, okay, whatever fossils are trapped within the sediments are preserved, that is why they are fossiliferous. And because they are fossiliferous, petroleum, natural gas, coal, okay, can be found in sedimentary rocks. Okay. Now, if I take the entire earth, most predominantly found rocks are igneous rocks. Okay, if I take the entire earth, most predominantly found rocks are igneous rocks. The entire continents will be made by igneous rocks. Why? Because igneous rocks are primary rocks. They are like parents. Okay. So one, the predominantly you can find igneous rocks, okay, on the entire earth. I am taking earth as a whole from core to the crust. Okay, predominantly you can find igneous rocks. But if I take only the crustal part, if I take only the first 20 kilometers of the surface of the earth, okay, predominantly you find sedimentary rocks. Predominantly you find sedimentary rocks. Okay. The strongest in igneous, metamorphic and sedimentary, the strongest of the rocks are metamorphic rocks. Okay, the strongest of the rocks are metamorphic rocks. The weakest of the rocks are sedimentary rocks. The weakest of the rocks are sedimentary rocks. Okay, so this completes. I have given you the examples here itself. These are the examples. Okay, so this completes sedimentary rocks. We have to do metamorphic rocks. I am really tired today, so we will stop the class here. Let's see. Sir, then sedimentary rocks are beautiful to look at. Why are they beautiful? Okay, fine. Something to do with iron too, apart from fossils. Fossiliferous, yes, Soumya, it has iron content also. Okay. Due to its decomposition, that is very entire. Anyways, fine. So more or less, what exactly means mechanically formed? Whatever I explained, a rock breaking, river bringing, depositing in the sites of deposition, sticking together, everything is mechanical. Okay. Strong with respect to strength. Okay, if with respect to strength, the strongest are metamorphic. Okay, you will learn tomorrow what metamorphic is all about, how it is formed and all. The strength, if I take metamorphic are the strongest, the sedimentary are the weakest. Okay, sedimentary rocks are mineral rich, but they are not as mineral rich as igneous rocks. Okay, these are fossiliferous rich. Their fossils are very rich. So whatever petroleum, natural gas and coal that you find, they are found only, not mostly, it is only in sedimentary rocks. Okay. Akash, burial need not be done in oceans, it can be done at some other places like river banks. Okay, but those burials are not predominant. Okay, I am talking predominantly for you to understand sites of deposition are oceans. Mostly oceans form a very good sites of depositions, but river banks can also be sites of deposition, lakes can be a sites of deposition. Okay, so burial can happen there also, but predominantly it is oceans. Please tell again about the size of grains of different examples you give. Prakar, yaar, someone give him the size. Okay, the size, because I don't want to write it again. It ranges from clay, okay, silt, sand, okay, gravel, cobble and boulders. So yes, Dhananjay, you can definitely leave the class. With great heat and pressure do form metamorphic. Yes, metamorphic we will get back tomorrow. Okay, so I hope you people have started reading the 6th standard, 7th standard NCERTs. Some people may read it slowly, some people may read it fast. It is okay, don't worry about it. Tomorrow's questions will be on tomorrow's topic that I will be doing, interior of the earth and rocks. So the questions will be on those things. So I may end up even giving you mains questions also. So please be prepared on interior of the earth and rocks topic. I will continue from tomorrow. We have to finish metamorphic and then I can go to interiors of the earth. Okay. Alright. So today's questions, okay, we will discuss it off. It is pretty easy. What is there in that? Okay. So first question, asteroids, okay, are found between the orbits of what and what? This is actually very simple. correct? So what is the answer? It is Mars and Jupiter. Okay. So next, cycle of seasons are caused due to, I hope you know you have got that in 6th standard NCERT. The cycle of seasons is mainly due to the revolution of the earth around the sun. Okay, how it happens I will explain in climatology. I will not explain it today or now because these are different chapter. I have taken these questions from 6th standard NCERT because I told you people to read 6th standard NCERT. Okay, the domain of the earth consisting of solid rock obviously is lithosphere. The continent of North America is linked to South America by isthmus. Okay, what is the difference between isthmus and a strait is, isthmus is a narrow land, strait is a narrow water body. Okay, isthmus is a narrow land, strait is a narrow water body. Isthmus is a narrow land that connects two huge lands, getting it? Isthmus of Panama, okay, connects North America with South America. It's a narrow land that connects both huge lands. Strait is a narrow water body. Okay, strait is a narrow water body that connects two huge water bodies. Okay, that connects two huge water bodies. Okay, a major constituent of atmosphere is nitrogen. Glaciers are found in mountains. Sahyadris, Western Ghats. Himadri is Himalayas. Okay. The oldest mountain range in India is Aravallis. It is older, very old. Okay, we will discuss it. It is very old. Where was it? Mangroves are found in Sundarbans. Imagine Sundarbans. Where is it? It is in the oceans, right? So saline water. During southwest monsoon, the moisture laden winds move from sea to land. Okay, it moves from sea to land. Simple it is. So continue studying. Make sure you continue reading the 6th standard to 7th, 8th, 9th NCERTs. Don't read very with lot of pressure. Don't make your life miserable. Read it to enjoy it. Okay, understand the concepts. Eventually, I am there to help you out with any concepts that are difficult to you. So don't worry about it if you are missing out here and there. Okay. Second is interior of the earth and rocks. Make sure that you study this. Tomorrow we'll be doing that. All right. So okay, guys. Thank you. We'll see you tomorrow. Have a nice day.